Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout hosted by Kawsar Kamal. Today, Kawsar is going to show you how to leverage Vault APIs and tools such as EnvConsul and Consul-template to allow frictionless integration with applications and benefit from dynamic secrets. I also want to note that the Hangout is recorded and the recording will be made available after post-processing, usually within about a day or two. I'll email out to all of you. The demo will take about 20 minutes and then we'll allow up to 30 minutes afterward for questions. So please go ahead and submit your questions throughout the demo. Anything that you have questions on as Kawsar is walking us through everything, you can submit them through the GoToWebinar terminal and we will answer them at the end. So with that, let's go ahead and get started. Go ahead, take it away, Kawsar.
All right, sounds good, Amanda. Thank you. Okay, so just real quick in terms of the agenda, we'll go through some introductions and then we'll look at the core Vault use cases and the setup that we have for this demo. And then we'll talk about two integration patterns with Vault. And then we'll look at how to list the leases that Vault has provided and how to revoke those leases and how the application can handle a sort of a lease revocation for a secret. And then we'll end with some Q&A. Just a little bit of an intro about myself. My name is Kawsar Kamal. I'm a senior solution engineer here at HashiCorp. I support the Northeast region. I'm based out of New York. And these are some ways you can get in touch with me. Okay, so as you may know, HashiCorp as a company, we're focused on the application delivery lifecycle, more specifically solving some common challenges that come across in this lifecycle. So where Vault fits in with all of this is providing a capability for centralized secret management, so managing the entire life cycle of a secret, creating it, renewing it, and then destroying it. And then also Vault provides an encryption as a service capabilities for applications. Now, one common question that I often get from customers is that, we understand that, Vault is great at providing a secure way to manage all of my secrets, but how can I benefit from Vault with my existing applications? So, generally I may have sort of a landscape of applications on-prem, or maybe I'm writing some new applications for the cloud. How can my applications integrate with Vault? Do I have to refactor all my applications, or is there an easier way to integrate with Vault, right? So that's sort of the topic of the webinar today. And the answer, right, to that question is that, it depends. Vault has a robust and comprehensive REST API, which is a primary way of interfacing with Vault. It also has a UI, a CLI, which are more for human-oriented workflows. Now, in terms of applications, you can sort of generalize and put applications in these two categories, right? So you can have an application that uses the native Vault SDKs and libraries to interact with Vault. So this means that the application must be aware of Vault in some way, right? So there's some kind of a secret SDK that you're using, or maybe you're just using the whatever runtime you have, right? Python, Node, Go, etc. And you're just sending HTTP requests to talk to Vault's API endpoint. So that's being represented on the left side of the diagram here. On the right-hand side, we have a use case. You may have a legacy application. It doesn't even have to be legacy. Maybe you're writing a new application for the cloud. However, you do not want to refactor that application, or you just don't want to introduce any type of secret management code in that application. In that case, we have a couple of tools out there that can help you inject secrets and still take advantage of Vault's dynamic secrets and use that to authenticate to a service in the backend. So for our demo, the service in the backend is MongoDB. And the legacy app that we have reads some credentials at deploy time using environment variables. Now, these two these two binaries that we have, these are supported HashiCorp tools. One of them is EnvConsul, which is one of the tools that we'll see today. A very similar one is Consul-template. Now, you guys may be aware of sort of HashiCorp's Consul product, which is a distributed key value store, and it all provides a comprehensive service mesh solution. These binaries here are separate from that, so I just wanted to make the distinction very clear. To use these binaries, you do not have to be using HashiCorp's Consul solution at all. Right? These are just sort of independent binaries that run as their own processes. So they can run as a sort of a sidecar process on a VM, or if you're running in a Kubernetes type of environment, they can run as a sidecar process in your pod. And the way they work is they are intelligent consumers of Vault, so they can retrieve a secret from Vault, and then when that secret is about to expire, they can renew that secret, and then once it retrieves that secret, it can deliver that secret in terms of an environment variable, or it can render a configuration file, and then sort of trigger an application reload or application restart. Right, so that's the setup that we have for this demo. So let me go ahead and exit this screen and kind of dive into the application a little bit more. So this is the application architecture. It's deployed in a AWS VPC and US East 1. It's a pretty simple application that's made of a couple of different microservices. We have a web client in the front, which is going to display as a web page to interact with, front-ended by Elastic Load Balancer. And then we have two API endpoints, right? And these are microservices as well. We have a listing endpoint and a product API endpoint. Both of them retrieve some data from a backend MongoDB database that's deployed and then display it to the web client. And the way these microservices are communicating with each other is that they're using Consul's DNS API for service discovery. So that's how, using these DNS names, the web client is able to find the listing API and the product API, etc. So all of this is provisioned through Terraform. As you know, in a sort of a cloud operating model, everything is somewhat dynamic. You do not know sort of the IP addresses and endpoints from beforehand, right? That's where a tool like Consul is, really handy to enable this type of inter-service communication. Okay, so if I go to my Consul UI, let me zoom in a little bit. As you can see, all of these microservices are registered and are registering as healthy. There are some health checks that are defined. The application itself has this listing endpoint, the product service, and the web client. And then we also have a couple of other ones. So we have MongoDB, which is holding some product information. And we have Vault, which is also running as a registered service. So let's look at the application itself. Again, this is a very simple application. This is the Elastic Load Balancer address, and I can interact with it. And if I refresh the page, as you can see, it's displaying some sample data that's present in MongoDB. Now, kind of what's going on behind the scenes is that the product API and the listing API is obtaining data from MongoDB, but in that process, it has to authenticate to MongoDB using some credentials, and it's retrieving those credentials dynamically from Vault. So let's see that a little bit more in action. Right? So let me go to my terminal window. All right, so this is my Terraform output. It's just showing sort of all of the EC2 instances that have been provisioned. I just provisioned it about half an hour ago. And I'm already logged into my Vault server here. So I'm going to use the Vault CLI at first. Let me clear the screen. And I am logged in as the root user. So do a token lookup. All right. So as you can see, I'm logged in as the root user. Now, to authenticate to Vault first, or to retrieve any secrets from Vault, first I need to authenticate with it, right? So now for this webinar, I'm actually using the AWS EC2 authentication method, where I'm presenting some metadata that the AWS platform provides me, And using that metadata, I'm able to authenticate to Vault and read a secrets path. The AWS authentication method is probably another topic for another webinar, because there are there are various ways you can set it up, and there are two types of authentication methods, EC2 and IAM. What I'll show here is a configuration that I did for the EC2 authentication method. Just as a high level, I'm restricting EC2 instances by my account ID. It has to be from these types of AMIs. So I actually have 3 AMIs here. MongoDB, the AMI that the MongoDB is running on, and then the product service and the listing service. And what's really important here is the policy. So Vault has a robust sort of access control system managed by policies, which dictate what paths I'm allowed to read. So if I sort of display this policy, right? Let me clear my screen. This policy allows me to kind of read a credential from Mongo Creds catalog. So if I sort of display it real quick, I can see that when I issued this command, it was able to reach out to MongoDB, dynamically create this username and password, and then deliver it to me. What's interesting here is there's a lease duration of 2 minutes, so which means after this 2 minutes is over, Vault will go and revoke this set of credentials automatically without having to do anything. So let's look at the integration patterns. As I said, there are 2 services. There's a listing service and a product service. Now, how can I kind of consume this secret from my application, right? So I'm in the source code directory for my listing service, right? I have a set of data kind of files for the application itself. This is a node.js application. During deployment time, it's a really simple application. This is a representative of a legacy application. During start time, it reads these 2 environment variables, and it uses these 2 environment variables to authenticate to MongoDB. If I actually look at this Systemctl Service, it's being started by this binary called EnvConsul, which I talked about before. EnvConsul obtains the secrets from Vault and then injects it into the application as environment variables. Right? So the 2 environment variables were the DB user and the DB password. So that's how the integration is happening. If we look at the EnvConsul configuration file, let's see here. It's actually listing underscore EnvConsul. Okay. This is the EnvConsul configuration file. Again, all of this will be posted in GitHub, but there's a secrets path, Mongo Creds catalog, where that command that we did before, Mongo Creds catalog, will provide me with a dynamically generated username and password. Okay. Now, I have actually introduced a metadata endpoint for this application, which shows me the current user ID and password that this application is using. Now remember, this set of credential will expire after 120 seconds. So after 2 minutes, we expect a new set of credentials. So we'll leave this here. We'll go to the second service, a product service. Now this is a Python application where I'm actually using the Python SDKs for Vault to integrate directly. It's called HVAC. So the HVAC import declaration is up here, import HVAC, and it allows this application to talk to Vault directly and then obtain secrets. I kind of introduced a method here called get Mongo Creds. It obtains an authenticated Vault client using AWS EC2 authentication. It reads the secret from this Vault secret path, which is, again, it's just Mongo Creds. And then it uses that to authenticate to MongoDB. Right. So if we kind of do something similar and we look at the metadata endpoint for this application, oops, curl. This is the current user ID and password that this application is using. So what we'll do here is we'll tail the syslog, and what we can do is kind of go back to this application, right? So this is kind of the web interface for this application. Now, as you know, Vault has this concept of lease, right? So instead of having static pre-created shared secrets, Vault will provide these secrets dynamically in terms of as a lease. So if I look up this sort of lease lookup endpoint, it'll show me what are all the leases that Vault currently has provided to my applications. This is actually easier seen in the Vault UI. So let me go there. So this is the Vault UI. As you can see, there's a MongoDB dynamic secret configured. If I go to access, there's AWS Authentication Method configured. But here's the set of leases that it has. And if I go into any lease, it'll tell me kind of the status of the lease, issue time, last renewal, and this lease itself will expire in a few seconds. So this is a very dynamic sort of environment, right? It's generating these leases and these credentials very frequently. Now, one thing I can do with this leasing model is that, say my application was to get compromised, I can actually revoke the secrets, revoke the lease. So I can revoke an individual lease, or I can revoke an entire path of leases. So what we will do is go ahead and sort of use this revoke force sys leases endpoint and go ahead and revoke all leases from this path. Now, when we did that, let's go back to the application and see how the application behaves. Right? So as you can see, the listing service is no longer able to communicate to Vault with using the previous set of credentials that it was using. But the product service is still able to do that. And the reason is we have some retry logic built into the product service, right? So if we go back to the tail log, what happened is the application tried to obtain a set of data from MongoDB right here, so in get products from DB. And then there was an error, right? It said there are no users authenticated. So the application saw that it obtained an authentication error because we revoked all the leases. It now newed up another Vault client. It used AWS Auth EC2 authentication method to authenticate to Vault and obtain a new set of credentials. So I have these debug statements here that are kind of showing this in process. In real life, you probably don't want to sort of output your password in the log. But essentially over here, this part here is showing sort of Vault response from AWS EC2 authentication. This is sort of the first step of retrieving a dynamic secret, and then the second step is to actually read the dynamic secret itself. So here we're sending a GET request to Mongo Creds catalog endpoint, and it's now showing sort of the actual request ID, and then here's the latest username and password, right? So using this retry logic, I'm able to obtain sort of the latest or a new set of credentials when I get an authentication error. You can make the retry logic more complicated. You can obviously sort of have a few different iterations built in. In my case, it only tries to retry. It only retries once and obtains one new set of credentials. And every 2 minutes, it's going to repeat this cycle, because every 2 minutes, this set of credentials is configured to expire. So Vault is going out there and revoking this set of credentials. Now, if we go back to the sort of the web page real quick and do a refresh, you can see the listing service is sort of working again. And the reason is, for the listing service, we were using EnvConsul, which was EnvConsul, just to kind of go back to the diagram, right, is reading that secret from Vault, and then when that secret expires, it obtains a new set of credentials. So it stopped working because we manually revoked the secret, but after that 2 minutes life cycle was up, EnvConsul went back and retrieved a new set of secrets and reloaded the application. So now the application is sort of working again, all right? So that brings us to the end of the webinar. Just in conclusion, we saw two integration patterns with Vault. One is using the Vault native APIs, using the Python HVAC SDK. Another was using EnvConsul, which is a separate tool that we have to retrieve secrets from Vault or to sort of retrieve key value information from Consul distributed key value store, right? And you may ask, well, why do I care about all of this, right? Why can't I just pre-configure a set of secrets for my applications? And then it's very easy. I don't have to worry about changing it, etc. So there are a few reasons, right, why we even bother with dynamic secrets. One is each instance of this application. So as you can see, there are quite a few different instances. So in this case, there are two EC2 instances each for these API endpoints, but it could be 20 or 50, what have you, in a production environment, in a dynamic cloud type environment. And the number of APIs could be many, right? It could be tens or hundreds of API endpoints that you have running as microservices. So in that type of environment, if you're pre-sharing a secret, there's a chance that a malicious actor could get a hold of that secret, and then now you don't have a way to know exactly which instance was compromised, because all of them are using the same secrets. Using the dynamic secret model, each of my sort of containers or EC2 instances has its own secret. So there's a much stronger sort of accountability or audit trail. You also limit the blast radius. So, because each secret has a lease time, if I get a hold of one secret from one instance, that secret is no good after 2 minutes, right? Because it's continuously revoking that. And then it also gives you the ability to revoke it. So, if through your sort of detective controls, you find that there was a compromise or a breach, you can go ahead and sort of revoke all of the credentials with just one command. And then, as you can see, you can make the applications resilient through retry logic, etc. And the application will just start working again after sort of the renewal time. If you're using static pre-share secrets, this is going to be very painful to sort of restart all of these microservices again. All right, so that kind of brings us to the end of the webinar portion. We'll move into the Q&A. I just wanted to recommend just two more things. So this is a blog post that Seth Vargo wrote. It talks a little bit about different techniques and integration patterns of using applications with Vault. This is written from a Chef perspective, but it's actually quite agnostic. So even if you're not using Chef or any configuration management tools, these patterns that he describes here are quite valid. In fact, in my case, this entire environment was provisioned through just bash scripting using user data. So I'm not really using any configuration management tool here. And then the last thing is, we'll post this in the webinar information page, but there is this GitHub repo where you can use this to sort of provision all of this infrastructure in your own AWS account. So all of this also present as infrastructure as code. All right, Amanda, so I'll hand it back to you and we'll move into the Q&A portion.
Okay, thanks, Kawsar. Awesome job. Okay, so we have a few questions, and so anyone with questions that you're kind of thinking about, go ahead and submit them, and we will ask them. So, Kawsar, first question. So someone's saying, using the EnvConsul and Consul-template, how do you inject the new secrets into a legacy app dynamically as the lease expires?
Sure. So EnvConsul and Consul-template are both quite intelligent. So let me bring up, I want to bring up one file that we can use to clarify this a little bit. It's actually in Packer. Actually, it's in the product service. So let me go back here. Let's see. Let me go to the listing service, which was using EnvConsul. And then if I go back to this file, what EnvConsul does is it reads a secret from Vault, right, using this path. it's intelligent enough to know that this lease is going to expire in 2 minutes. So before the 2 minutes is over, there's a grace period. So in my case, it's 15 seconds. So exactly 15 minutes, 15 seconds before the 2 minutes, it'll go back and retrieve a new credential, right? So it will reread this path, retrieve a new set of credentials, and then it will restart the application. In my case, right, the application is being restarted through this command. So it's opt listing service, listing wrapper. So I have a shell script that's actually, triggering the application itself. You don't necessarily have to sort of restart it. It might be an arbitrary command where you can trigger an application reload. So in my case, it's a sig term signal that I'm sending. You can have the application handle it to just reload the secret, and then this way you don't have to kill the process. But yeah, the answer is both of these tools, EnvConsul and Consul-template, will manage the life cycle of the secret, so your legacy application does not have to know about when does that secret expire. Right? EnvConsul and Consul-template will handle it for you.
Okay, awesome. Okay, next question. So this is good to back up a little. Someone's asking, what's the difference between EnvConsul and Consul-template?
Yeah, that's a really good question. We will include the relevant links in the webinar page, but to answer your question, both of those tools are sort of HashiCorp provided tools. They use the Go templating language. EnvConsul specifically will read a secret from Vault and inject it to the application using environment variables. So when I say inject, what this really means is it'll read a secret from Vault, it'll set those secret key value pairs as environment variables, and then it'll start a child process, right, for that application, where the child process will have those secrets available as environment variables to read. So that's EnvConsul. Consul-template does something similar, but instead of setting environment variable, it writes out a configuration file. So a common pattern with any application is, during start time or during runtime, it reads the path in the file system, which has a set of key value pairs or properties, which configures the application, right? And part of that configuration can include sort of your username, password, or whatever secret information that's relevant to the application. So Consul-template will write out that template file, and it uses a Go templating language, which is very flexible, and I encourage you to go check it out. It'll write it out just sort of in the format that the application expects it. And then, when the secret expires, it'll go write out a new file and then trigger an application reload to go read that file again. So that's sort of the difference is one deals with environment variables, and other deals with writing out configuration files.
Okay, awesome. Thank you for the clarification. That was great. So, okay, next question. Someone wants to know how many secret calls can a Vault node handle per second or per minute?
Sure, yeah, that's a really good question. So that gets into the Vault architecture a little bit. In the Vault Enterprise version, you can scale out horizontally and allow it to read, allow many reads per second. When we have done some sort of basic benchmark testing, we can get into the tens of thousands to 20, 30,000. Obviously it depends on from a single instance, and obviously it depends on sort of the type of CPU and memory that instance has. But those are some, very high level numbers. It also depends a lot on your use case, right? If you're reading sort of the secrets dynamically, then it depends on, how quickly the backend is responding, right? So if there's a network connection between Vault and MongoDB, where Vault is sending a request to MongoDB, asking it to generate a new set of credentials, and then MongoDB will return that back to Vault, right? So, you have to kind of take that latency into account, and also take into account how many requests can that backend handle. A lot of times, this is not really, this turns out not to be a huge issue for applications. A lot of times the amount of transactions Vault can handle per second is quite high. It is written in Go, and it is sort of compiled down to a binary. So, the performance is quite high. I'm sure there is another use case for Vault called encryption as a service, where you can do sort of bulk encryption and decryption. And that's where we start to really see sort of a transaction per second conversation. Because if you're sending a lot of data to Vault, sort of bulk data to encrypt and decrypt, that could end up being a time-consuming and CPU-intensive operation. And that's some of the benchmark numbers I was talking about, where we can go up to sort of 5,000 transactions per second to 10,000, etc. And then it just depends on the resources you have assigned to that Vault instance as well. So, to answer your question, it really depends. It depends on quite a set of different parameters. It depends on the use case, but those are some of the high-level benchmarking that we have performed.
Okay, perfect. Okay, next question. Which data sources does Vault support in addition to Mongo?
Yeah, that's a good question. So Vault actually supports a variety of what we call secret engines, right? And they don't even have to be sort of databases, right? They could be anything else. So let me just share another screen real quick. If you go to Vault documentation and you click on secret engines, you'll sort of see all of the different options available here. This concept of leasing and dynamic credentials can be applied to any backend service. So, as an example, so the example we used for this webinar was MongoDB. So out of the box, right, the databases that we support, there's Cassandra, HANA, Microsoft SQL, MySQL, PostgreSQL, Oracle. These are sort of support out of the box. It works in a plugin architecture. So if you have a sort of a database that's not listed here, like Sybase, or something else, you can write a custom adapter for it. So you have to implement a few methods that go and talk to that backend database and sort of has the logic and understands or can interact with the driver to go handle dynamic credential creation, credential renewal, and revocation, etc. But that's sort of the database dynamic secrets engine. You can have other secret engines. For example, you may be provisioning into AWS, right, or any cloud, Azure, GCP, etc. And to provision into those services, you need a set of credentials. So in addition to databases, Vault can also dynamically generate sort of Azure credentials, AWS credentials, etc. So to answer your question, the supported ones, the latest ones are sort of it's probably easier if you go into our docs and just kind of look at all the secret engines that are there out of the box, and then you can always extend it by writing your own custom secrets engine.
Okay, great. And then kind of on that note, kind of touched on this, Kawsar, but if there's anything you want to add. So someone's asking, could you describe how you configure Vault to manage MongoDB credentials?
Yeah, we'll be happy to. So this one, in our docs, if you go to database and MongoDB, it actually kind of walks you through how you set it up. The way I have done it for this webinar is very similar. So let's kind of walk through this, right? It'll probably take 30 seconds or so. First, you enable the secrets engine. In this case, it's a database secret engine. You don't have to enable it in the database path. In my case, I enabled it in the Mongo path. So for example, you can enable this secrets engine many times. One could be Mongo Dev, right? Mongo Prod, or Mongo for a specific application, etc. Once you enable the secret engine, you provide a privileged set of credentials to Vault. So that credentials, in this case, this is admin and password. Now, obviously, this is an example, and you provide Vault with the connection URL, right? So in this case, for example, we're writing Vault write database config my MongoDB database. So this could be, Vault write database config, production MongoDB database as an example. And then you provided the admin user ID and password. That username and password has to have enough authority to go sort of generate a set of new credential. It doesn't necessarily need read access to your application database, it only has to have enough authority to generate a new credential and sort of revoke the credential. Vault also provides a way for you to rotate this credential. So there's a way to rotate what's called a root credential. So you don't have sort of this credential configured as a static credential. This can be rotated by Vault as well. So once you have configured the database endpoint, then you configure one or more roles. So in this case, this is just called my role, but it could be a dev role, a prod role, maybe a sort of a read-only role. And the way roles work is, imagine like you have a DBA team. The DBA team probably should have access to all of the databases, right? So you may configure a role called the DBA role, and in the creation statements, you say that the role for that dynamically generated credential should be read-write, and it should include all of the different databases that you have. This is a natural thing. Technically, the DBA should have access to different databases. But then you may have a dev role, right, which for sort of separation of duties and least privilege, where the developers only need access to the development database. So the dev role, you may configure the creation statements to say, DB, you just say the dev Mongo database. And this is an array, so you can pass in multiple databases here and configure that from beforehand. You may have a read-only role, so maybe somebody just needs to go troubleshoot. So then they can dynamically obtain a credential from Vault and then only perform read-only operations to that database. So at a high level, you enable the Secrets Engine. You provided information for the database endpoint and the privileged username and password, and then you create one or more roles, which then provides a login endpoint for the end user to obtain a dynamically generated credential and then go authenticate against the backend.
Okay, awesome. Thank you for walking through that. Okay, so next question, how does it work with apps that use data connection pooling?
Sure, that's a good question. Apps that are using database connection pooling, it's more or less transparent to the application. So when you have a connection pool, generally like you have a set of user ID and credentials that you're passing, and then you sort of have a min connection and a max connection. So say the pool has a min connection of 5 and max connection of 10. And then depends on the way the connection pool is configured. So when that credential expires, in my case, I'm using a very low TTL of 2 minutes. But when that credential expires, most likely that connection pool is going to be invalid. You're going to have to introduce some logic where it sort of reinitializes a new connection pool with a new set of credential, right? Unless the connection pool allows individual connection using a different set of username and password. So it depends on the specific driver. I know some drivers are quite intelligent and they may have connection pools with sort of different username and password for each connections, whereas other connection pool may be implemented as just a static configuration, which has sort of one set of username and password, and then once that username and password is invalid, you have to sort of create and refresh the entire connection pool. So again, it really just depends on the specific driver and the database you're using. If you want to get in touch with us, more than happy to research that a little bit further for your use case and provide more information there.
Okay, thank you. Okay, next question, Kawsar. How do you manage automatically regenerating and rolling out the TLS or certificates for legacy apps? So like Nginx, Java, etc., using Vault PKI. And they're asking, can it be done 100% through Vault, or is this something like Consul-template necessary?
Yeah, that's a good question. So let's break it down a little bit. So I think that the first part of the question is, how do you generate sort of dynamic TLS certificates, right, for applications, and a common use case being Nginx. So we were talking about the secrets engine before. We do have that PKI Secrets Engine. And what this allows us to do, and I assume you're already sort of familiar with the PKI Secrets Engine somewhat, but just for the benefit of the audience, the PKI Secrets Engine, just like we generate a dynamic secret credentials for Mongo, it allows you to dynamically generate TLS certificates. And the setup here is you configure a root CA in Vault, and then you configure one or more intermediate CAs. And then once you have the intermediate CA, you can quickly generate leaf certificates by using the Vault APIs. So just like we sent a login, just like we sent a read command to go read a database credential, you can send a read command and it can send you the TLS certificate. So once this PKI engine is set up, now the next part of the question is how do you integrate it with Nginx or legacy applications? Generally, Nginx has a configuration file, right, where in the nginx.conf file, you have path to a private key and you have path to a certificate. Using Consul-template, you can read the TLS certificate from Vault that's dynamically created, and then you can write those out, right, to the paths that Nginx expects, right? Could be /etc /nginx /ser certificate.pem, or and then private key.pem. And then you can trigger an arbitrary command through Consul-template. So you can say, Nginx reload, and then Nginx will reload the configuration file. And then in that process, it will pick up the new certificate and the private key that Consul wrote out to the file system. So the answer is yes. In case of Nginx, it's not an intelligent Vault consumer. So you have to sort of add a tool like Consul-template to go consume these certificates or any secret from Vault, write it out to the file system, and then trigger a reload into Nginx. And this would happen with the legacy application as well. So if you have sort of microservices that are communicating with each other using TLS, then you can sort of use Consul-template to front end it, obtain this TLS certificate dynamically during deploy time, maybe through configuration management, and then write it out to the file system, and then have the applications pick up those certificates and private keys. This is sort of the legacy way of doing it. I encourage you to go check out Consul-template, where you can sort of get a lot of this functionality out of the box. You can sort of have legacy applications communicating with each other over mutual TLS using Consul-template, and Consul-template can generate all of these certificates for you in a very easy manner. So there's actually a webinar that somebody else did with this same application showing Consul-template, and we can kind of link that in the webinar info page as well.
Okay, great. I can do that. Perfect. So a few more questions. Thank you, Kawsar. Everyone is responding how helpful this has been from the viewers. So next up, how does the service app authenticate to Vault to obtain the dynamic credentials?
Yeah, that's a great question. So that's using the AWS Authentication Method. The nice thing about Vault is very good at establishing an identity. So whether it's a human being, like a human operator, or an application, it can determine, right, who this end entity is. And based on my identity, it will allow me to kind of retrieve a secret. And that access control, the authorization part, is handled through the policy language, right, the Vault policies. The authentication part is handled with something called sort of authentication method. So if I go to the Vault documentation, there is something called authentication methods, and we have a variety of different authentication methods here. So let me zoom in a little bit. As you can see, some of these authentication methods like LDAP, right, Okta, GitHub, Radius, these are more human oriented. So if you're running a Active Directory server as a human operator, I can provide my LDAP or AD credentials to Vault based on my group membership in AD. it will authorize me to go retrieve a certain secret, like from a certain path from Vault, right? That's the human workflow. For applications, however, right, it's unusual to configure an application with a sort of an AD credential. We have these other set of authentication method. In my case, right, I'm using the AWS authentication method. So I think the question was on the listing service. So both the listing service and the product service, they're running on AWS EC2 instances. And if you kind of double click on the AWS authentication method, it goes into more details, but at a high level, there are two types of authentication method. There's an EC2 authentication method and an IAM credential authentication method. If these services were running as a Lambda function, for example, I would use the IAM authentication method. Because these are running on EC2 instances, I'm actually using the EC2 authentication method. And I can sort of authenticate based on some metadata that was provided to me by the AWS sort of metadata service. So what I want to do is kind of show you that, right? So I am logged in, I'm SSH'd into the EC2 instance itself. If I hit this endpoint, this is the EC2 metadata service, there's the instance identity document, right? This is something that AWS is providing me. So I can authenticate to Vault with two pieces of information: this identity document and this PKCS signature of this document. So AWS has provided me with these two pieces of information in this metadata service. I present this information to Vault. Vault can cryptographically validate that, yes, this request is indeed coming from this specific EC2 instance with this instance ID, because it trusts AWS, right? So in this case, we have delegated the trust to the AWS platform. And based on sort of that validation, Vault issues me a token, and then I can use that token to retrieve secrets from Vault, in this case, MongoDB credentials. So to answer your question, it uses AWS EC2 authentication, and to authenticate it, it uses these two pieces of information, and then it's able to go read the secret from Vault. There's a lot more details here, and so the authentication workflow, EC2 and IAM, and there are quite a few different parameters that you can pass in. In my case, I'm restricting the authentication from, I think I had it here, from a specific account ID and AMI ID, but I can provide quite a few different other restrictions like region, subnet ID, etc. So to answer your question, that it's using the AWS EC2 authentication method.
Great. Okay. Thanks, Kawsar. We have just a few more. So dynamic secrets require Vault support for a particular service like MongoDB. So they're wondering what do they need to do to handle their own dynamic secrets integration with an internal proprietary service.
Understood. Okay. So if it's a database, for example, I think that maybe if you want to follow up with the type of backend, right, that you're interested in. If it's a database that we do not support, for example, we don't have Sybase DB here. I've actually been working with a mentor of mine here, Roger, who has been sort of working on a Sybase database plugin. And what he has done is implemented this custom database secrets engine, right? It kind of tells you it's an interface that you implement in Go. So it has to be in the Go runtime. So, we're able to find sort of a database driver that's written in Go, and then you have to implement a few methods, and they could be things like creating actually it provides the interface right here. So you have to implement these methods in the Go programming language. Once you have implemented these methods, you can import that as a custom plugin, and then you can have Vault manage the secret lifecycle dynamically by using your custom plugin. Now, if it's not a database, right, if it's something else, I'll have to look into that further. Generally the request is for a service such as database. But in general, Vault is, any HashiCorp product is quite extensible, right? All of these are open source. And everything that I've shown in this webinar is part of the open source version, and it's not enterprise. So technically, you can go fork our Vault repo and then introduce your own sort of custom secrets engine as well.
Perfect. Okay, two more questions, Kawsar. So this one, so someone's asking, do Consul-template and Consul support .NET web apps and or Java web apps? So they're talking about like Windows
Right.
devices.
.NET WebEx. Okay, so Consul-template and EnvConsul is written in the Go programming language, and Go has compilers for Windows as well, right? So let's talk about .NET first. You can technically download, sort of compile EnvConsul for Windows and run it there, and Consul-template as well. Both of these are written in Go. They compile to a binary, so, without dependencies on the system, so they are quite performant. Personally, I have not tested on Windows, but I know that we have many customers that use sort of Vault on Windows as well. I have not tested these tools specifically on Windows, but so the answer is it should work. It's just I don't have sort of a reference point right now, but yeah, you should be able to get EnvConsul and Consul-template sort of working on Windows as well, because they'll compile down to a Windows binary. When I look at the documentation, I don't see any sort of restrictions that it mentions on Windows, and we'll provide the documentation on the webinar info page as well. I think the second question was on Java. Absolutely. So when you're using EnvConsul and Consul-template, it's sort of abstracted from the runtime. So regardless of whether it's a Java app or Python app, etc., right? The application expects the secrets to be in a configuration file or to be in an environment variable. So EnvConsul and Consul-templates is simply providing those secrets in form of an environment variable and a configuration file that the application knows how to read from the file system. So regardless of what the runtime is, you can use these tools, right, agnostic of the application runtime. And if the question is along sort of, can I integrate a .NET application directly with Vault, right, the answer is yes. So if I look at the Vault, there is a place where we sort of, so if I look at Vault integration, okay, so I probably don't have it handy, but we'll link to it in our webinar info page. But Vault has sort of a set of libraries, right? So it has the REST API first of all. So in any programming language, generally there are facilities to make REST API calls. What you'd have to do is configure so the application or sort of codify the application to have intelligence to read a Vault token or to have or use an authentication method like I'm using here with the AWS EC2 authentication method and directly hit the Vault API endpoints and then obtain authenticate to Vault and obtain a dynamic secret from Vault, sort of interact with Vault from the application runtime itself. So that's sort of that second pattern that I was talking about, where you're natively integrating Vault with your application. Now, in terms of sort of SDKs, I'm just looking this up. I'm positive that there is a .NET SDK as well. Let me see here, HashiCorp Vault. Yeah, so if I go into the Vault HTTP libraries, there's a C# implementation. So, so using that, you can interact with Vault. So what I've done here, and we'll link this on the webinar page, but this sort of tells you all of the integration points that are available. I am using the Python HVAC library, which is listed all the way down here. Yeah, so the Python HVAC. So this is what I was using, this library here. I found it to be very well documented and easy to use. It actually did not take me too long to introduce AWS Authentication Method using that provider. But yeah, if you scroll up, there's a C#, so there's a Vault Sharp API, it looks like, which you can install and sort of use natively from your application. Again, I have not personally tested it, but it is out there as a community supported provider in our documentation. It looks like it's a fairly active repo. I mean, there's sort of commits happening within the last couple of months.
Great. Okay, thank you. And okay, final question, Kawsar. So kind of expanding on that, someone's wondering what Linux capabilities does EnvConsul need to work?
You do not need much sort of dependencies at all. The nice thing about Go is it compiles down to a binary, right? And generally, like these binaries do not have any dependencies. So if you're sort of a user of HashiCorp product, one thing you'll find is that we try to make it as easy as possible for all of our products to be consumed. So when you say, how do I install Vault and get it up and running? Well, you just download the binary and you just start using it. Like it's as simple as that, right? You just go to our downloads page, just get the binary, put it on your path, and you can start using it on Linux. And we have binaries published for sort of all of the common platforms like Linux, Windows, etc. With EnvConsul, I was able to download a Linux binary. I'll check if there's a Windows binary, and if there is, I'll link to it. This is reference to the earlier question somebody asked whether it's supported in Windows, and if there's no Windows binary readily available, you can certainly compile it. But sort of getting back to Linux, I was able to just download the binary, and it worked out of the box. I actually have sort of that initialization code in our GitHub repo, and if I minimize this, if I go back to my GitHub repo, you'll see that there is a init file, right? So init listing. So in init listing, actually it's in the Packer file. So if you go into the Packer directory, there is and we'll link to all of this. I just wanted to show you kind of the way this works is there's a install client tools.sh that you can use. So if I go to install client tools, it's under files. Let's see, install client tools right here. All right, you can use this bash script to install EnvConsul and get it up and running on your system right away. There is no like system dependencies here. I was using an apt-get based system, so I was using Ubuntu. You can use a Yum-based, like a RHEL or CentOS-based system as well. But as you can see, I'm downloading EnvConsul and Consul-template here using just simple curl commands. I untar it, and then I just put it in my path for Linux. So the answer is very easy. You just download the binary and put it on your path. Just to extend that, just 10 more seconds. Earlier I mentioned about Vault. I'm doing the same thing with Vault. So I'm interacting using the Vault CLI just for troubleshooting purposes. So again, I'm just downloading the Vault binary from sort of these publishing endpoints that we have, and then I'm just putting it in my path, and it's available for me to use.
Awesome. Okay, thank you, Kawsar. So that wraps up Q&A. Thank you for powering through all those questions. We got a lot of positive feedback from people. So I hope your questions got answered. And I hope you all enjoyed today's Hangout and have a better understanding of how you can use Vault with your legacy apps. Thanks for hanging out with us. And a big thank you to Kawsar for his time today. As I mentioned at the beginning, this Hangout was recorded and we will make it available on our website after processing. I will send an email out to everyone who registered with that recording link. So with that, that wraps things up for us. Thank you. Have a great day. Goodbye, everyone.
All right. Thanks, everyone.